Hello good day viewers. In this tutorial we are going to find a solution to this interesting system of exponential equations. We are given that x to the power of y is equal to 1 divided by y squared and y to the power of x is equal to 1 divided by the square root of x. And we are looking for the values of x and y that can satisfy both equations. Not that both x and y cannot be equal to 0 because our denominators cannot be 0. All right, let's get started. I want to tag this equation as equation 1 and tag this one as equation 2. Let me start with equation 2. So from equation 2, we have y to the power of x equal to 1 divided by the square root of x. This implies that square root of x is equal to 1 divided by y to the power of x. You can just switch them, right? So from here, we can square both sides in order to find x. So we are going to square the left-hand side and also square the right-hand side. If you square the left-hand side, you'll be left with only x. And if you square the right-hand side, remember that you can take out this x from here. So you have 1 divided by y to the power of what? 2x. This is an important equation. We are coming back for that. And let's call this equation number 3. Remember, we used equation 2 to form this equation 3. Now let us substitute it into equation 1. So put equation number 3 into equation number 1. What is equation number 1? Equation number 1 is x to the power of y is equal to 1 divided by y squared. So x to the power of y equal to 1 divided by y squared. So wherever we have x in this equation, we are going to plug in 1 divided by y to the power of 2x. So therefore we have 1 divided by y to the power of 2x. But because we have y here, we're going to raise it to the power of y. So it is the same thing as 2xy. This is equal to 1 divided by y to the power of 2. You know from one of the laws of indices, this and this are exactly the same. So what condition will make this statement true? Observe that the bases are the same, which implies that the exponents must be the same, right? 2xy equal to 2. Or the base, which is 1 divided by y, equal to 1. Because you can see the bases are algebraic terms. So it is either 1 divided by y is equal to 1, or the exponents are exactly the same. So from here, you can divide both sides by 2. You have x, y equal to 2 divided by 2 equal to 1. We can divide both sides by x. We have y equal to 1 divided by x. What about the other one? You can just take the reciprocal of both sides. So you have y equal to 1. So we have two values of y. But remember, we have the value of x from equation number 3, which is x equal to 1 divided by y to the power of 2x. Let me just copy that. So here is our equation number 3, but we have two values of y. Y could either be 1 divided by x or equal to 1. Let's start with the first one. When y is equal to 1 divided by x, wherever we have y in this equation, we are going to substitute it with 1 divided by x. So to the left hand side, we have x. This is equal to 1 divided by y, but y is 1 divided by x. This is to the power of what? 2x. Therefore, x equal to what? X to the power of 2x. And x can be raised to the power of 1 naturally. So what does this imply? It means that either 2x equal to 1 or x itself equal to 1. From this one, you can see that x is equal to 1 divided by 2 or x equal to 1. So remember that y was 1 divided by x. So we have two combinations here, x, y. When x is 1 divided by 2, 1 divided by 2, remember that y is just the reciprocal of x, 1 divided by x, right? And 1 divided by 1 divided by 2 will give us just 2. And the other one, we have x and y. If you consider x equal to 1, we have x equal to 1. But what is y? Y will be 1 divided by x, which is 1 divided by 1, also equal to 1. Now we have two solutions. But remember that we have another value of y, which is equal to 1. We are also going to substitute it in that equation. So this is the equation, but y is equal to 1. So we have x equal to 1 divided by 1, right? Because y is 1 to the power of 2x. 1 divided by 1 is 1, and 1 to the power of 2x is still 1. So x equal to 1 here. Therefore, when x is 1, y is also equal to 1, but we already have that combination here. So we have only two combination of solutions here. When x is 1 over 2, y is 2. And when x is 1, y is also equal to 1. And you can test them in the main equations to see whether this is true or not. Thank you for watching. Do share to your learning colleagues. And don't forget to subscribe to my YouTube channel for more exciting videos. Bye-bye.